So I'm going to talk about how we might build soil's natural capital and highlight some of the issues that I think have prevented us doing that, and at the end provide what I've called an oven-ready deal so we can start building that natural capital now. So soils provide a number of ecosystem services that many of you will be aware of. The sort of principal ones most people refer to are carbon sequestration, water purification, climate regulation and nutrient cycling, as well as the provision of food. But there's other sort of more subtle ones that are often forgotten, and we referred to that this morning about the sort of biodiversity in the soil and how that's a sort of principal source of pharmaceuticals. Up to 50% of our antibiotics come from soil organisms. So our soils are under considerable pressures. I've given two examples here. On the satellite photo on the left, this was after one of the heavy storms during 2 or 3 years ago. And you can see there's significant soil erosion occurred, and that can be seen in the Bristol Channel, where you've got the very heavy sort of brown colour affecting the channel, where you would expect a sort of more of an aquamarine colour. And then the right-hand side, the very famous Holme Post in the Fens, and that was first planted in 1870, and it's now 4 metres above ground. And that has been a result of two processes, drainage of the Fens for agricultural production, and also erosion as a consequence of the lighter, non-wet, non-drenched peats being eroded quite easily by winds. And obviously, as they become aerated, those fenland peats can become oxidised, and we lose carbon from those peats. And peats are a vital carbon source critical to our delivery of net zero. So we've done some evaluation, but Cranfield led this study looking at degradation of soils, and this valuation came to about 0.9, 1.4 billion. And again, that was principally down to loss of soil carbon as a result of greenhouse gas emissions that were consequent from that carbon loss, but also the replacement costs of those carbon. In this study, quite a crude study, they used the cost of replacing it with manure. But that probably underestimates a lot of the role that carbon has in soils in other cases, like water retention and water filtration in order to remove contaminants. So I would say that's probably an underestimate, but it does prove that we can do some evaluation of some of those ecosystem services that soils provide. So the first bit of legislation, if you like, the first aspiration to manage our soils sustainably came in the Safeguarding Our Soils document from 2007. And that targeted 4 issues whereby we were to manage our soils more sustainably. So our agricultural soils were to be better managed and threats against them addressed. Soils would play a greater role in the fight against climate change. That's principally about reducing NOx emissions, but also enhancing the carbon content. The soils in urban areas would be valued, and their development in construction practices would be addressed. And then the pollution of our soils would be prevented and contaminated land legacy dealt with. But I think you can quite easily argue, if you look at the data that we've presented, that on all 4 of those targets, we're failing currently, or we're not dealing with them as well as we potentially could. So we know what we've got to do, but we're not doing it just yet. So why have we not delivered on those sustainable soils? Well, I think there's 4 key reasons, and I'll try and address these in the rest of my talk. So I think there's a perception that soils are inherently complex and therefore difficult to deal with. And that's resulted in disagreements around metrics and about whether we need different metrics for different soils, for different land uses. That might be true, but I think we can address that. As we referred to throughout the day, we have no real baseline. We've got a few snapshots of what the state of our soils is, but we do not have sort of repeated measures at 5-yearly intervals, for example. And really the regulation around soils is minimal if you contrast it with air and water. And I think we do have to be thinking about soils in the same breath as air and water. So this just gives you an idea of the complexity of the different soil types across England and Wales. The purple areas are our blanket peats, the red areas are our freely draining sandy soils, and the yellow areas are our sort of more base-rich soils over limestone. So though our soils are very, very diverse, we do have good knowledge of what they are and where they are in the country, so we can adapt metrics to each individual areas, and as Kathy showed earlier, we can quite easily use that sort of soil information to look at where we might want to regulate water flows. So as I said, there's been some discussion about what the most appropriate metrics are and how do we design a campaign. Well, we've done it twice already. We did it with the National Soils Inventory run out of Cranfield, and we did the Countryside Survey run from the Centre of Ecology and Hydrology. But also the Environment Agency in the mid-2000s got together a lot of stakeholders to design a UK soils monitoring network. So we already have a monitoring scheme in place ready to go. And if you just look at the right-hand side of the slide, you can see that they developed for certain land uses, arable, permanent managed grass, managed semi-natural grass, action levels for, this is for soil organic carbon. So for arable, they wanted a progression towards 50 grams per kilogram for England and Wales. And then in permanent managed grass, they wanted that to go up to 75. Usually in grasslands, you have higher soil organic matter than you do in arable rotations, mainly due to the permanent vegetation cover, but also due to the lack of tillage before each crop. And this is another stakeholder workshop where we were looking at the different land uses. Here we chose 4 land uses: urban, intensive, extensive and forestry. And then we looked at 5 indicators, well, sorry, more than 5, 6, 7 indicators: organic matter, water retention, earthworm structure, nutrients, microbial diversity and contaminants. And we were looking at the key questions that the stakeholders had raised. One was, what was the relationship between management and soil health? And these went right through down to the communication of different soil health indicators to practitioners. And you can see that organic matter features in virtually all of those landscapes as a key indicator when we're addressing those different questions. Urban is slightly different because often the concern is around contamination. Sorry, I've gone too quickly. So I said we've done a number of surveys. This survey I'm showing the data from here was undertaken by the Natural Resources Institute, now part of Cranfield University. And they looked at the rate of change in carbon between 1978 and 2003. And you can see here that there was quite a, if you look at the contrast between those two dates is on the right hand side and the original values are on the left hand side. And you can see the bigger changes, the dark blue colours, tend to be in those areas where we have peats, where we're seeing sort of erosion due to drainage, but also one of the most significant changes was in arable landscapes. And you can see that towards the east of the country. So we know when we do national surveys, we can pick out key changes in our natural capital. So we can do the surveys and we can prove that we are seeing these changes over time. And it's really critical that we maintain these. There hasn't been a national survey at this scale since 2007, which was the last countryside survey. So one of the things that I think we've really not been able to deal with is there's been very poor regulation of soils. This was one of the issues in Europe. There was going to be a soils directive, but this didn't come about because the northern industrialised countries such as the UK knew that their soils were polluted, and they may well have to spend a significant amount of money to bring those up to natural levels if they ever could. So I think that's why we don't have a directive such as the Water Framework Directive. But standards do exist for soil contamination. That's predominantly an urban problem, so in terms of total coverage it's quite low. We do have the good agricultural and environmental condition requirements as part of the basic payment scheme, but it's very easy to get a derogation for that if you've had a difficult year. There's very few inspections to discover non-compliance. One report I read recently said there was only 2 prosecutions in 2015. So that just shows you the level of coverage that the EA has, probably just due to resource limitations. But they don't really combine a holistic approach to soil health. So we need something stronger if we're going to really improve our soils. And then for many habitats, such as woodland, we don't have any regulations at all. So really weak regulation around soils. However, we do have, certainly for arable land, we know how to restore soils. Sort of 4 key principles: provide continuous living roots. They pump carbon into the soil, so we're always enhancing that carbon, and that carbon feeds the biodiversity within the soil. Minimize disturbance, that stops oxidation of the carbon. Maximize soil cover, that reduces erosion, which can have ongoing impacts on improving in treatment of water. If you've got a lot of dissolved organic carbon in the water, it makes it very expensive to clean for drinking water. And then we also want to maximize our biodiversity by using things like cover crops with diverse seed mixes. These can be turned into 6 key management actions. So you reduce inversion tillage and reduce soil traffic to prevent compaction. You increase your organic matter inputs, use cover crops, manage nutrients and rotate crops. And finally, reduce the pesticide usage, because that can have penalising effects on some soil organisms. So just briefly then to conclude, the oven-ready deal for soils, as I see it, is we need to give soils the same protection as air and water. If you look at the improvements in our water quality over the last 15 years, they've been quite remarkable. We could do the same for soils. Soils need to be placed at the heart of the ELMS scheme. We don't want the weak regulation that's gone with the good agricultural and environmental condition. And we need to take a census to develop the baseline of our soils. And I've showed you some good data as to why that can lead to some really good outcomes in how we start to address the problems that have been identified. Thank you.